right now. Every day I burn my circuits. I burn my circuits, I burn my circuits. What should I do? Oh, of course. I need to design a short circuit protection for my circuits. Every day I burn them. Now my MC is gone. Wash! This is our circuit that we are going to use to protect from short circuit. As you know, and as you have spoken by a time back, short circuit causes a lot of dangers to our systems and installations. So we basically need to protect it because it may cause fire, as we have discussed in the later video. So I see right now we have the relay, we have the LED and the resistors. These resistors are the limiting resistors for the LED. We have the push button. This is how this circuit works. Right now, if I have my input from here, my plus is already connected to the load. This is my load. The plus is already connected, but the minus is not connected. So here we don't have a complete circuit. So this load, if it is an LED, it will not give out light because the minus is not completed. But this is how it works. When I power my it will move up to here. So when it reaches here, this ground is in normally closed and my load is in normally open. So if I press this button, I'm going to provide a ground to my coil. If I provide a ground to my coil, so this coil will be energized. If it is energized, it's going to attract this conductor to go up here. If it goes up here, you see now, here, my load has power. And now, due to the fact that this normally open, it is connected to the ground pin of the coil. So, my conductor will remain closed. Then, my load will have power. But, what happens? What happens indeed? What? If I come back, I short these lines. Once a short circuit, I short them. Bam! What's going to happen? There will be a malfunction between the circuit. So if there is a malfunction between the circuit, due to the fact that this circuit is going to sense high current moving to it, so the malfunction will cause this relay to lose voltage. So if it uses voltage or current, so it's going to drop this conductor back to the normally closed. So now my circuit will be open. So that's our short circuit protection. Then I'll have been protected my circuit from short circuiting. As in the circuit diagram, we have discussed of how this circuit is going to be operating. So let us start connecting our circuit on the breadboard. So far we use a breadboard because a breadboard is good for prototyping. So in our circuits, we had a relay module. This is what we call a relay. We had LED, this one is an LED, and we had two of them. So this one and this one. We had a push button, yeah, that is it. So we also had two resistors that we are connecting to our LED. Into our circuit, we also add wires, and today we are going to use these jumper wires to work as our connector wires. We had the power side, the power source, which will work as this one. So let us get started. After connecting our circuit properly, this is how it operates. This is my push button, which is on the circuit at the left. So when I press my push button like this, it loads to my lines. So as per now, my lines, the output, they have power. But if I try to short circuit the output like this, look properly, exactly like this, whoop, this guy is gonna switch off my circuit. So after switching off my circuit, it will work properly. Let us do it again. So it will need resetting. So resetting, I remove the plus after I connect it back. Then I press my button, sweep, it loads. But if I try to short circuit it, and under any case, you may short circuit it when you don't know that you're short circuiting exactly, but you short circuit it like this, it will automatically switch off. Yeah, hope this video was helpful to you. Thank you for watching. Please like and subscribe to our channel for more interesting videos like these ones. I know they are educating. So if you have any comment about this video, just write to me in the link down in the description. You get all the circuit diagrams, the programming circuits, and everything that you need to stay together with our circuits. Thank you very much.